For this project, we're going to be creating a script that predicts values using machine learning. So it's going to work like this. We're going to have an input such as years, and we're going to also get some past data from those years. So for example, I made, let's say, 1,000 euros the first year, I made 800 euros the second year. On the third year, I made 2,000 euros and so on. We're getting some sort of pattern going. And what I want to know is what's going to happen in 15 years. What will my salary look like in 15 years? And to do that, we're going to use machine learning and linear regression. It's going to use that machine learning and it's going to spit out a prediction along with the accuracy rating of that prediction. And we can also set the number to something much further, such as 30. What's my salary going to look like in 30 years? If we follow this data. If we run the script again, we'll see that in 30 years or on the 30th year, I'll be making 14,000 euros. And we also have a way of showing this on a plot so we can actually see what we are doing. So if I set plot here to true, it's going to drag us over to our main window and it's going to show us a plot of the data that we've input. So this is the line that it is following based on these inputs. The dots are the inputs, so those are the years, and the outputs are the salary. So as you can see, it made a line that fits this data quite well. Anyway, this is a great project for getting into machine learning. So let's get started immediately by creating a new empty project. So once you create an empty project, open up your project folder and create a new Python file. And this one's going to be called model because we want to model our data. And we're going to import from data classes the data class so that we can type @data class and we can create a prediction class. So prediction, and the prediction is going to hold a value of type float. It's going to contain an R2 score, which I'll explain later, of type float. It will have a slope of type float, an intercept type float, and a mean absolute error of type float. And we will create a string representation that will say return f prediction with the self.value formatted to 2 decimal places. And that's also going to contain the R2 score. So self.R2 score, and that will be formatted to 0.2%. So it's going to give us a percentage back. And that's all that this model is going to contain. Then we can move on to main.py and get started with the packages. So let's open up the terminal and type in pip install scikit/learn. And that's going to contain a lot of functionality that we need to actually get this machine learning in motion. Then we also want to install pandas, and we need to install something called matplotlib. And I believe those are the only packages we need to install to make this work. So let's close the terminal and try. So from model, we're first going to import our prediction. Then we can import stuff such as NumPy as MP, import pandas as PD, which are both naming conventions, import matplotlib.pyplot as PLT, and from sklearn.linearModel, we're going to import linear regression. Then from sklearn.metrics, we can import the mean absolute error and the R2 score. And finally, from sklearn.modelSelection, we need to import train test split, which is used to train and test our models. Then we can create a function called make prediction, and it's going to take some inputs of list of type string, or of type float actually, and some outputs of list of type float, and an input value, which will be used to make a prediction. And this will be of type float. Then there's also whether we want to display a plot or not, and that'll be of type Boolean, initially set to false, which will return to us a prediction. Then for this to actually work, the inputs must match the length of the outputs. So we're going to create a very early check to make sure that that's the case before doing anything. So if the length of inputs is equal to the length of outputs, that means we did something good, but that's actually not what I wanted. I wanted this to be not equal to. So if length of inputs is not equal to the length of outputs, then we're going to raise an exception that the lengths of inputs and outputs must match. So the user knows that both of these must be of the same length. Then we need to create a data frame for our data. So that's going to be a data frame, which will equal pd.dataframe. And it's going to take the inputs as inputs and the outputs as outputs. Of course, the outputs should also be the outputs from above. Then something very common in machine learning is reshaping the data using NumPy. And we're going to use two naming conventions. One is X and one is Y. X in general is used for inputs and lowercase y is used for outputs. So for example, X is going to equal a np.array, so a NumPy array at the data frame index of inputs. But we need to reshape this data. So we will reshape it with -1 and 1. And we need to do the same thing with lowercase y. So lowercase y, which will handle the outputs, will also be reshaped. And something I always encourage you to do if you don't understand what it does is just printing out what it is. So we're going to print X and Y, for example, and we're just going to test this make prediction. So right now we'll enter some inputs of 1 and 2, and outputs will be 3 and 4. And we also need to specify input value, and we don't need to do anything with the Boolean. So we're going to use that just to test this. Now, if we run the program and make this prediction, you'll see we will get this data reshaped in this kind of fashion. If we do not reshape it, for example, you'll see that we'll just have a normal array, but we want to reshape it to look like this. So that's why we use this weird reshape method. Next, we want to split the data into training data so that we can test our model. For every time we create a model to run in machine learning, we're going to have some test data and some training data. The test data is just used to validate our model to make sure that it is accurate. So you'll see this a lot, but there will be something called train X and test X. Then we'll have train Y and test Y. And that's going to equal train test split with X and Y as the data. We're going to provide a random state at 0 and a test size of 20%, so 0.20. Random state just means we're going to always get that same random data back in case we want to find out where something went wrong. You can change this to any number you want, but we're going to leave it at 0. Now that we have the data split up into testing and training data, we can actually get started with making some predictions. So first we're going to create a model of linear regression because we're going to be using linear regression to make this prediction. And we're going to call model.fit. And we need to fit the train X to the train Y. So that is the training data. And based on the training data, we're going to be able to make a prediction. So below that, I'll add a comment called prediction. And the Y prediction, because Y is the output, is going to be equal to the model.predict. And we need to create a list that is 2 levels deep. So 2 square brackets, and inside we can enter the input value, the value that we actually want to predict. Then we also need a line to display on the chart or the plot, and we're going to call this Y line, which is the prediction line. So model.predict X. And that's going to give us the slope, or that line that was red going through all the dots in the chart. So I'll show you that later, but we need that. Now to test for accuracy, so we'll type in testing for accuracy, we're going to create a variable called Y test prediction. And that's going to equal model.predict test X. And I didn't create the plot function yet, so we're going to add a to do here. To do or before we add the to do, I'm going to create a comment called plot. And if plot is active, or if plot is set to true, which by default it is not, we're going to show a plot. So we're going to first create an error here. So we're going to raise not implemented error that says plot function has not been created yet. And this is a great practice to use when you have functionality that has not been created yet, because if you just type in something such as pass and you call this, later on when your project gets bigger and bigger, you might not understand why you're not getting a response. Anytime you don't have functionality, return something that is very descriptive. A not implemented error is going to really help you debug later. So I strongly encourage you to always use not implemented error over pass. But we will create that in just a moment. Let's just finish this function. So at the end, we want to return the data. So here we can type in return a prediction. And the prediction is going to have some interesting values. First, the value of the prediction is going to be the y prediction at the index of 0 at the index of 0. Because right now we are 2 layers deep, or 2 levels deep in the list, which means we need to get out of those 2 levels to actually get the value back. Then we have an R2 score, and the R2 score is going to be the R2 score followed by the test y and the y test prediction. So all the R2 is going to tell us is how good our data fits the linear regression model. Because in machine learning, you have many different kinds of models, and the linear regression model is only good for linear data, which means if data is going in a certain direction, linear regression will give you a general idea in which direction it is going, and it can make a prediction based on that. But if you have data that goes up and down like a roller coaster, you'll probably use something called polynomial regression. So all the R2 score does is tell us how good our data fits the linear regression model. If it's a high score, it means our data is rather reliable. Otherwise, it's going to tell us that it didn't really make any good predictions. So that's actually what the R2 score does. It's not entirely just the accuracy of the prediction. It's more about how our data fits the linear regression model, in other words. Anyway, next we have a slope, and the slope is exactly what it sounds like. So model.coefficient, and here we'll get that at the index of 0 at the index of 0. So if year 1 we have 50 and year 2 we have 100 and year 3 we have 150, the slope is obviously going to be 50, and that's what it's returning to us. So it's good to have that if we want to use it. Then we also want to define the intercept, which will be the model.intercept at the index of 0. And that just tells us where the line crosses over the y-axis. And we can also have the mean absolute error. So mean absolute error is going to be the mean absolute error of test y and y test prediction. And the mean absolute error is just going to give back to us a solid number that says, okay, our calculation is probably going to be off by 50. So it's going to be plus minus 50 of whatever the prediction is. So we have the prediction function down. All that's left to do is to create the plot and also to just insert some information to make a prediction. So we're going to create a function called display plot, and it's going to take some inputs of type list of float and the outputs of type list of float. And we also need to provide a y line. Then we can call plt.scatter, and we need to scatter the inputs and the outputs. Then we're going to set the size to 12. The plt.xlabel is going to be equal to inputs, and the y label is going to be equal to outputs. Then plt.plot the inputs with the y line, and we're going to set the color of that to red. We want the line to be red. And finally, we want to show this plot. So plt.show. And that's usually the biggest mistake I make, is to forget calling .show, and then I never understand why the plot doesn't show. So always remember to call plt.show. Now, instead of having this not implemented error, we can now replace that with display the plot, and the inputs are going to be set to x. The outputs are going to be set to lowercase y, and the y line is obviously going to be equal to the y line. So now we have a way of plotting the data or showing the plotted data if we want to. All that's left to do is to test out our prediction function. So if name is equal to main, we're going to create some sample data. So in this case, I'm going to create some years of list of type integer. So here we're going to have the first year, second year, third year, fourth year, fifth year, sixth year, seventh year, eighth year, ninth year, and 10th year. So 10 years of data. In general, the more data you have to feed the model, the better. 10 is a good starting point, but I would not limit it to that. And because you already get what I'm trying to do here, I'm going to paste in the earnings. So for the first year, I have 1,000. For the second year, I have 800. And for the 10th year, I have 4,800. So we have some sort of growing number that's correlated to the amount of years. And we want to guess what happens based on an input we provided. So my input, for example, of type integer is going to equal 20. We want to see what this will be like in 20 years. So just like that, we can type in prediction of type prediction is going to equal make prediction, and the input or the inputs is going to be set to the years. The outputs are going to be set to the earnings. The input value is going to be set to my inputs, and we're not going to print or show the plot just yet. We're just going to test that everything works. Then we can print that my input was my input, and we want to print the prediction. What did we get back from that prediction? So just like that, we can run this script, and it might take a bit of time the first time, depending on how strong your computer is. And it's going to spit out to us this prediction. As you can see, we got 9875 in 20 years, which looks about right, because 4,800 times 2 would be around 9,600. So it looks like it's following the pattern quite nicely. As soon as you have numbers that start to simulate a roller coaster, such as if you enter 10,000 here and let's say 0 here, you'll see that this percentage is going to drop drastically because the data is not going to fit the model as well. It's not going to know why this went up to 10,000 or why this went to 0. It's going to be a bit more confusing. So the more linear the data is, the better. And a better way to show this is actually just to display the plot. So we'll just set plot to true. So right here, if we run the program with plot set to true, we will get our plot back with the line prediction that tells us in which direction we are going. But as you can see, this is linear. The dots are going in a certain direction. As soon as we start doing something funky, such as saying this is 3,000, this is 2,000, and this is 1,000, we're going to create an arch. And if we create an arch, we're going to have a line that doesn't represent our data that well. Something better would be an arch that goes up and down. So the linear regression model does not really work here that well. And as soon as we close this and go back, you'll see that we don't really get that good of a prediction. It's just the wrong model. It even gave us an R2 score of 0%, which is awful. So linear regression is one of the first models you will learn about when you're learning machine learning. And what you really need to know is just that it has to be going in a certain direction for it to actually make sense to use it. But one more thing I'm going to show you that you can do, because we have prediction data, we can also guess what's going to happen in 20 years, 30 years, 40 years, all at the same time. So for example, we can print something such as year 30, and here we'll type in prediction dot slope times 30. I'll do 40 and 50 as well. 40 years and 50. So now if we run this script, but first I'll set plot to false, you'll see that first we'll get the prediction for 20 years, but we'll also get a prediction for 30, 40, and 50 years, roughly. So there's a lot of cool stuff you can do with this prediction if you want to get a general idea of what the future value is going to be. And I also want to show you one more thing. So print, let's say prediction dot mean absolute error. Every time you print this, it's going to tell you that the value is going to be plus minus 325. The prediction is going to be 9,875, but that might be plus 325 or that might be minus 325. This is how far off it might be. But anyways, I hope you enjoyed your first lesson in machine learning. We created a very cool value prediction script. Now it's up to you to play around with it, add your own data, maybe take it from a CSV file, and just make some cool predictions.